Welcome guys on Crazy for Concepts, and today I'm going to cover the topic hemostasis. Now I've tried searching this video on YouTube, but I didn't find any video with clear-cut explanation of hemostasis. That's why I've decided to make video on this topic. So let's begin with our topic. Now what does hemostasis means? Now suppose we have a blood vessel and blood is flowing in it, and due to any reason it gets damaged in a particular part. Now obviously blood will try to move out. To prevent this from happening, there is a very beautiful mechanism in our body by which blood in this part becomes solid. And this solid part is called as clot, and in medicine it is more appropriately called as thrombus. Obviously, once it is formed, blood now will not move out and the leakage will be stopped. Now, why did we call this formation of clot or thrombus as hemostasis? If you see this word, it has two parts in it. Hemo, which means blood, and stasis, which means to stop. So since this clot is stopping blood from moving out of the blood vessel, that's why we term this formation of clot as hemostasis. Now this hemostasis has been divided into three steps. First is vasoconstriction, second is platelet plug formation, and third is coagulation cascade. And we're gonna see each of these in detail, but let me tell you the overview of each of these. In vasoconstriction, what happens is, as soon as blood vessel is damaged, blood vessel becomes constricted, and it happens due to two reasons. One is neuromuscular response to the endothelial damage, and second is when endothelial gets damaged, they release a chemical which is called as endothelin. This also constricts the vessel. And what is the purpose of constricting the vessel? The purpose of constricting the vessel is to reduce the volume of blood going into that blood vessel, so the leakage of the blood is less, right? Now the second is platelet plug formation. In this, what happens is, suppose we have this damaged part of the blood vessel. Now from the blood, platelet will come and attach to this damaged part and form a platelet plug. So this was about platelet plug formation. And in coagulation cascade, what happens is, from the blood, a protein called as fibrinogen is broken down into fibrin, and that fibrin is deposited on this platelet plug, and it gets interlinked and makes this platelet plug more strong and converts this primitive platelet plug into secondary primitive plug. So this was the overview of different steps of hemostasis. And before we move into the detail of each, I want to make certain words clear. The one word is homeostasis. This word is used as the ability of mammals to maintain their constant body environment no matter in which condition they move. So this is homeostasis. Don't confuse it with hemostasis, although they sound very, very similar. The second word we have is stasis of the blood. This phrase is used in inflammation, that whenever we have a tissue damage, blood vessel in that part becomes dilated to take more blood out there, and so we can have leukocytes and other proteins to take care of the damaging factor. So in that, due to dilation of blood vessel, the speed of blood becomes slow, so it kind of slows down. For that we use the word stasis of the blood. Again, it has very similar meaning with hemostasis, but they are different. And the third word that we have is thrombosis. Now till now, I have told you that whenever we have a damaged blood vessel, clot forms in that part. But the reality is, suppose we have a blood vessel, and even if there is no physical breach but little bit damage on the endothelial surface, then also blood can clot. The formation of clot in that condition is called as thrombosis, and it's a pathological condition because in this case, the clot is not serving any useful function. Rather, it is obstructing the lumen, and if it gets detached, it can move somewhere else in the cardiovascular system and cause blockage there and different complication. So this was the overview of hemostasis and some confusing word. Now let's move on to the detail of platelet plug formation. Okay guys, now let's talk about the second step of hemostasis, which is platelet plug formation in detail. Now this step also has three steps in it. First is adhesion, second is activation, it is also called as secretion, and the third is aggregation. Now, before moving on into detail of each of these, let me tell you the overview of each of these so that your concept is clear. So in adhesion, basically what happens is, in the damaged vessel, platelet cups and bind to the subendothelial connective tissue. In activation, what happens is, once they are bound to subendothelial connective tissue, they'll become round in shape and they'll start secreting certain enzymes. And those enzymes, in the third step, which is aggregation, attracts more and more platelet, and that primitive platelet plug becomes bigger in size. So that was the overview. Now let's move on to the detail of adhesion. It's a very, very simple step. So let me reorient you with the diagram. So here we have subendothelial connective tissue, and the main component of this subendothelial connective tissue is collagen. And above that, there are endothelial cells. Now, when there is a damage into the blood vessel, the subendothelial connective tissue are exposed, right? And the second important thing that happens is, due to the damage of the endothelial cells, they release a protein which is called as von Willebrand factor, right? Now, these von Willebrand factor come and bind to subendothelial connective tissue on one side, and from their other side, they bind to platelet through their glycoprotein 1b receptor. So this was all about adhesion. The second step of platelet plug formation is activation. In this step, what happens is, as soon as platelet binds to von Willebrand factor through its glycoprotein 1b receptor, it gets activated, and also some other chemicals bind to different receptors on platelet and they also activate it. Now, after activation, from flat plate-like shape, it is converted into round and flagellated shape. And in fact, since by default they are flat in shape and plate-like, that's why they are called as platelet. And after activation, they are converted into more round and flagellated shape. Now, if I tell you about platelet a little bit more, just like RBCs, they also don't have vesicles. RBCs don't have vesicles so that they can accommodate more and more hemoglobin inside them. Similarly, platelets don't have nucleus so that they can accommodate more and more vesicles in them, having different enzymes. And these vesicles, as you can see here, these are also called as granules, and they are divided into basically two types, alpha and beta. And beta granules are also called as dense granules. Now, each of these stores a lot of different kind of enzymes, but they are very difficult to remember all of them. Most important are thrombohexane A2 in alpha and ADP and calcium in beta granules. Now, thrombohexane A2 and ADP will help us in our third step of platelet plug formation, and calcium will help in coagulation cascade. Now, after the activation and conversion into more round and flagellated shape, these vesicles or granules through degranulation comes on the surface of platelet, and these different enzymes are released into the lumen of the blood vessel. So this part is called as secretion. And also one more thing happens which mostly students miss is that negative phospholipid molecules are also expressed on their surface, which we'll see how it helps in coagulation cascade in a while. This was all about the second step, which is activation. Okay, now let's move on to the last step of platelet plug formation, which is aggregation. Now in this, what happens is, as just we have learned that in activation, a lot of different chemicals are released, with the most important ones from them are ADP and thrombohexane A2. Now what these chemicals does is they modify the certain receptors on platelet which are called as glycoprotein 2b3a receptor, and these receptors, once modified, bind to fibrinogen, as you can see, and therefore these receptors help one platelet to join the platelet, and therefore the platelet which are once already bound to the von Willebrand factor attaches and attracts more and more platelets above them, and therefore this platelet plug grows and form a proper platelet plug. And thrombohexane A2 does the same thing and amplifies it. Just remember the difference between glycoprotein 2b3a receptor, which are helping platelets to bind to fibrinogen, and glycoprotein 1b receptor, which helps platelet to bind to von Willebrand factor. So this was all about aggregation. If we talk a little bit about clinical correlates, there can be certain congenital diseases due to problem in any of these receptors and protein. For example, if in a patient there is a congenital malformation in von Willebrand factor, this protein, then the person will have clotting disabilities, and in that case the disease will be called as von Willebrand disease. Whereas if there is a problem, genetical problem in 1B receptor, in that case the disease will be called as Bernard-Solier syndrome. And if there is a problem in glycoprotein 2B3 receptor, the disease will be called as Glassman thrombosthenia. So this was all about platelet performation, and in the next video I'm going to talk about coagulation cascade, which is the third step of hemostasis, in detail. So if you found this video useful, please hit like button, subscribe and comment down below. Thank you very much.